Okay. Test is tomorrow. I could do tomorrow. All right, now I'm just gonna go a couple in each section. Um, you might want to take your spiral home. This first section deals with the basically our first 4 pages in the unit. Hold on just a second. All right, so the first 4 pages had the two whites with simplifying that you had the Ed puzzle with. Then I think it was like a purple or pink paper with multiplying radicals, and then the extra examples. It was a half sheet. So the first 4 pages deals with the radicals. Now, in order to simplify, because this is the key here, yes, you're going to follow the rules, but you have to know your perfect squares. So let's talk about just the first 15 that are the numbers that represent perfect square. Always 1, then what comes after? What's the next perfect square? 4, 9, 16, 25, 36, sorry, 49. These are the ones we need to know by heart because these are the numbers we're going to use to simplify. You want to always use the largest one. All right, after 49, 64, 81, 100, 121, 144, 169, 196, and then 15, 225. These are the numbers we want to use to simplify. So you need to know those numbers by heart. Yes, you can use your calculator to help find the number, but you want to start dividing by these perfect squares. Okay, so like on a problem like this, 45, we're trying to find a perfect square that goes into 45. That would be 9 times 5. In the video, I reference making sure you box your perfect square because that number is gone and you take out the perfect square. The square root of 9, so what comes out is 3. So your answer is 3 root 5. Okay. Now, for a problem like number 5, the square root of 200, what perfect square goes into 200? Yeah, 2 times 100. The 100's the perfect square. That's gone. When we take square root of 100, we get 10. So we have 10 root 2. Okay. So I'm going to go to the next row. Try to do it as I'm saying what to do, or maybe write the problem or write the steps on your own before I show it and see if you're on the right track. Okay, I'm going to look at number 7. We need to talk about when you have a coefficient. The 2 is the coefficient, but we're still going to keep that 2 there and come up with my factors of 20. Seven. So let's try it, write it, see if you can find the perfect square, see if you can simplify it. This is the time to gauge if you can do these skills so that you can do it on the test. Move on to the, are you done with that? Okay, if you're done, you can move on to the other thing that you need to finish. Are you done with this problem? No, we are on 7. Okay, so what I'm saying is move on to the next problem that you need to do. We should have this roots, the factor, 4 and 5. 4 is the perfect square, so that's gone, and what comes out? The 2. The square root of 4 is 2, but here's my concern. Make sure you get this right. Factors on the outside of the radical get multiplied together. The answer is 4 root 5. Now, you are going to have to multiply and divide radicals. When we divide, we simplify first if we can, but if we can't, we rationalize. We cannot keep a radical at the bottom in the denominator. So on number 9, there is a root 5 at the bottom. I cannot keep that there. So what is the next step? You have to multiply by that radical to the top and bottom. That is called rationalizing it. So you have root 5 and root 5, not just 5, the square root of 5. And at this point, we should be multiplying straight across and simplifying. So sometimes you're going to have a radical answer. Sometimes it will simplify to a whole number. So this answer should be root 5 over 5. That's the final answer. Now with the problem like 11, the square root is over the whole fraction. So you should split it up and put the root over the top, the numerator, and over the denominator. Do that first, then simplify it. Because right off the bat, I see root 36 is a perfect square. So now my numerator is 6 over root 5. And we're back to what we did on number 9. We cannot keep the root 5, the radical 5 at the bottom, so we rationalize it by square rooting or multiplying by the square root of root 5 over root 5. We're just multiplying straight across. So this cannot, 6 is an outmate. It's outside the radical. I cannot multiply to what's inside. So that 6 stays outside the radical. And then 5 is now at the bottom. The whole point of rationalizing is to get rid of that radical. So I don't need to write root 25 because the square root of 25 is 5. Anytime I have the same radicand and I'm multiplying it together, it gets rid of the radical. Oh yeah, sorry. Okay, so 6 root 5 over 5 is the simplified answer. Now when you get to a problem like 13, the root 45 and the root 9 are both underneath the radical, so they're both inmates, they're both radicand. This is one where I would simplify first. Can 9, which is underneath the radical, go into 45? How many times? So then this would simplify, keep the 2 outside the radical, to 2 root 5, and you're done. I don't necessarily have to rationalize if I simplify it first. So sometimes when you rationalize the fraction, the ratio can be reduced. 15, you do need to rationalize, so that means you have to multiply by root 6 to the top and bottom. When I do that straight across, okay, this becomes 2 root 6 over 6. And this right here, the 2 over 6 can be reduced. So this would make it 1 root 6 over 3, or you can just say root 6 over 3. Because 2 6 can be reduced to a third. Okay? So if it can be reduced, make sure you reduce that. And then when multiplying, remember outmates and inmates don't mix. What's outside, the coefficient, gets multiplied together. And what's underneath the radical, the inmates, the radicands, get multiplied together. So we're going to end up with 12 root 60, but this can be simplified. This can be simplified So what perfect square goes into 60? Because the 12 is going to stay outside the radical. 4 and 15. Yes. So 4 is the perfect square. That's gone. And now what comes out? 2. So this 2 is going to get multiplied to that 12. So we have 24 root 15. Okay. All right. On the next page here, we have some more simplifying, dividing. Okay. So on number 19, the radicands are 27 and 8, but 8 cannot go into 27. So you can rationalize it, but I would simplify it first. I can simplify 27 with 9 times 3. I can simplify the root 8 with 4 times 2. The perfect square, 9, is gone. It comes out, it's a 3. And so with the 4, comes out, it's a 2. So now what I have is 3 root 3 on the top and 6 root 2 on the bottom. I cannot keep the radical root 2. Now I rationalize it. Going straight across, only the 3 and the 2 inside the radical can be multiplied together. So this is 3 root 6. And when I multiply the root 2 times root 2, you end up with a 2. And so I multiply those 6 and 2 together. So this is 3 root 6 over 12. And the 3 over 12, that can be reduced. So you end up with root 6 over 4. So if it can be simplified, I would simplify it first. Like on 21, the radicands is root 72 and the root 3. Can 3 go into 72? That's the first thing I would check. Can I divide 72 by 3? Yeah, what do you get? Hold on. Root what? Or 24. Okay. So this is going to be, let me get my pen, 6 root 24 now over 10. And now all I need to do is simplify the root 24. What perfect square factor goes into 24? 6 times 4. Take out the square roots and simplify. You will need to reduce. Oops, wrong one, sorry. 4. So now we have 12 root 6 over 10. And the 12 over 10 can be reduced. Yeah. So 6 root 6 over 5. All right, so that's simplifying. Odds are these questions are going to be open-ended. So you're going to have to show your work and get to the simplified radical. Just a heads up, okay? So now we're going to go to now we're using this skill with right triangles. So The majority of the rest of the test is applying the skill on a shape, which is going to be the right triangle, either with geometric mean or on the coordinate plane, okay?